In this section, we're going to start off our blackboard and behavior tree work, and we're going to make it so that when the AI spots the player, it will just run straight towards them. Now, to begin with, go over to the behavior tree. I prefer to open the behavior tree because you can flick between blackboard and behavior tree really easily like that, whereas I think if you open the blackboard itself, you can't just switch back to the behavior tree. So open the behavior tree. Over on blackboard though, we want to add two keys to our blackboard. So keys are like, what does our AI know? Where is it heading? What's its target? Things like that. And we want one key to represent what state is our AI in, patrolling, chasing, or searching for the player. So we're going to go add key. Remember that state information we set up as an enumeration, so I want an enum key, and we're just going to call that state. And then over here on the right, we can say, well, which enum specifically do you mean? And we can choose our enemy state one. So now this blackboard key can have a value of patrolling, searching for player, chasing player. We also need another blackboard key to represent what is our current target, like where are we walking to? Are we trying to get to the player? Are we trying to get to a waypoint? So we're going to add a key of type object, and I'm going to call that target. And then over on the right, we can expand key type, and in base class just set it to actor. So we can set that target to anything that is an actor in a real engine, and then that's a nice easy way of making our AI walk right to it. Back in the behavior tree, how does this work? Well, we need to set up like a tree of logic which represents our AI's decision-making process. How does it decide what to do? And then what is it going to do? Well, to begin with, it's going to do different sets of things depending on which state it's in, whether it's in patrolling, chasing, or searching for player. So we need three what are called sequences, one to represent each of those states, and we need a selector, which is how it will choose which of those sequences to execute. So to start with, if you click and drag away from root, and when it asks you what you want to make, add in a selector. What a selector will do, you can put as many things underneath selector as you want, and we're going to have our three sequences. In fact, let's put those in, and then I can better explain what it does. So off of the selector, add a sequence. It's in composites sequence, or what I normally do is just type SEQ for sequence in the search, and you'll find it there. And if you spell it right, that helps. Right, there we go. So whenever our behavior tree runs, so our AI is working out what to do, the selector will choose one thing underneath it and one thing only to run. So it will either run this sequence, or this sequence, which will represent our three states. If this sequence fails to run, because it tries them from left to right, so say this one fails to run, say this represents the patrolling state, and we're not in the patrolling state, it will try the next one along. If that one does successfully run, let's say this is our chasing the player state, and we are chasing the player, it will run whatever we put underneath that sequence, and then it won't try to run the third one. So a selector starts from left to right, trying each of its immediate child nodes until it finds one that can run, and then it will run that. So it will only run one. A sequence, on the other hand, will try running every node from left to right that we put underneath it. Okay, so we're going to have, like I said, these represent our three states. How are we going to do that? Well, if you select this sequence on the left and right-click on it, you've got the option to add what's called a decorator. Now, what decorators let us do is choose the conditions under which a selector or sequence or a task or whatever will run or won't run. And we want to go add decorator blackboard, and it comes up with this thing, blackboard-based condition. If we select that, we can choose in the details panel that we want this to be run if blackboard key state is equal to patrolling. So whatever we wire up underneath this sequence will only run if this blackboard state that we just made is equal to patrolling. And then we need to do the other two. So right-click on the middle sequence, add decorator blackboard, select that new blackboard-based condition and say that one is going to be for state is equal to chasing player. And then finally the right-hand one, add decorator blackboard, select the blackboard-based condition, and this one is state is equal to searching for the player. And now we can have underneath these three sequences different logic, different thinking we want our AI to do depending on which state it's in. But we're not quite done yet, because at the moment, let's say we're in the patrolling state executing our patrolling tasks, and then all of a sudden we see the player. it won't just abort this sequence. It will keep on running through its patrolling tasks until it finishes, and then we'll be able to react to seeing the player. What we want is for all three of these Blackboard-based conditions to be able to abort their sequences if the state changes. And to do that, we just select the Blackboard-based condition, and for this one, we're going to go observer aborts self, which means if the condition that lets this run, state is equal to patrolling, changes, it can abort all of its tasks. And also, let's rename this. So instead of Blackboard-based condition, we'll just call that patrolling. Then this middle one, we will also set that to abort self if it's if the state changes, and we'll call this which one's this? This one's chasing, isn't it? And then finally, this one on the right, we'll set that to abort self and call that one searching. All right, perfect. But how do we determine which of these three states our player is in? Now, initially, we're going to do it just with patrolling and chasing, and then we'll bring searching into it in a few parts later. We're going to decide this with something called a behavior tree service. Now, a service, and you can see at the top here, we can go new service, is just a little bundle of code, a little bit of blueprint we can create, which will run every so often on a timer, and we get to choose how often. So if you want your AI every 2 seconds, check can you see the player, you could make a service, have that set up to can you see the player, and run it every 2 seconds. And we're going to do something similar to that, which is going to run it more frequently. So we're going to click new service. Now, annoyingly, Unreal doesn't give you the choice right then and there, what do you want to call this new service? It's just called BT service _ blueprint base, this new asset here. If I go to the content browser though, I can see that new service that it created, BT service blueprint base new, and I'm just going to rename that. I'm going to call it BTS _ something. So I tend to start all my behavior tree services with BTS _. You don't have to if you don't want to. This one's going to be called BTS _ check C player. BTS check C player. And that's going to do what it sounds like. So how's this going to work? Well, to begin with, our service is going to start with a receive tick AI event. So event receive tick AI. That will be fired by the engine whenever the artificial intelligence needs to run this service. So it's like begin play or tick in normal blueprints. And we need to know, can you see the player? Where controlled pawn represents the the character of the pawn that is running this behavior tree. Now we want to access the AI perception component in BP enemy. So first of all, we'll take controlled pawn and do a cast to BP enemy, which will try and treat it basically saying, is the thing does controlled pawn refer to something that is a BP enemy or that can be treated as a BP enemy? If it does, then from there we can do a get AI perception component, which we added in the last video. And then from there, we can do a, we want to know, can you see, what actors can you perceive? And that is just a get perceived actors, which returns us an array of all the actors that can be seen by whichever sense we put in here. And we're going to use the sense of sight. That's the only one we set up, remember. So we can ask this array, which is basically just a list of things that the AI can see. Does that array contain, so contains item, and then the player character? So we can click and drag back from here and just do a get player character. Now this is going to return a Boolean value, true or false. True if the AI can see the player, false if it can't. We can check that with a branch. But if you didn't know, the shortcut for branch is just hold B and click, which is what I would normally do. So if you see me do that without explaining it, like if a branch is just appearing, it's just hold B, click. Right, now let's wire that up. So that goes in there, that goes in there. So try treating the control pawn as a BP enemy. If that works, get the perception component and ask true or false, can you see the player? Now, if true, all we're going to do initially is set our blackboard key. Where's that blackboard gone? Our blackboard key state to be patrolling. How are we going to do that then? Well, we need to, inside that service, create what's called a blackboard key selector, which is just a variable. We add new variable. I'm going to call this BB key state, and that variable needs changing to be of type blackboard key selector. There it is. And it needs to be instance editable. Like you need to open this little eye icon here, otherwise we won't be able to set it in the behavior tree to what we need to. I'll explain more about that when we get back to the behavior tree. So what a blackboard key selector does is it lets us access a blackboard and either set or read values from it. So drag BB key state into here, say get BB key state, then drag off of that and do a set blackboard key as, and then see, here's all the different types of blackboard keys. Now state, if you remember, was an enumeration. So we're going to do that, and then what are we going to set it to? Well, we want to set this to our patrolling. No, if we can see the player, this will be chasing, sorry. If we can see the player, we want to set the state to chasing. Now, do you remember, state, like you're chasing, patrolling, whatever, was part of this enemy state enum that we set up. So what we do here is right-click and search for literal enemy state. And that gives us a variable with our 3 values in. So we'll set that to chasing player and just wire that into there. There are ways of tidying up these. So you can get this to appear as 1 node rather than 3, but for now we'll leave it like this. When we start doing more states, we'll definitely do that. And then we want a copy and paste of those 3, so Control-C, Control-V down here. If you can't see the player, for now, we'll say just go into the patrolling state, although that logic will change. Now if you can see the player, what we also want to do is set that blackboard key target to be the player character. And that works in a similar way. We need another blackboard selector, blackboard key selector. So I can just copy that variable by right-clicking, going duplicate, or pressing Control-W, and just rename that one BB key target. Then I can drag that in. And remember, this one was a object key, wasn't it? So we go set blackboard key, set blackboard value as object. And saying, okay, which object do you want to store in there? And that's just going to be the player character. So we can drag off of that and do a get player character. And that's all the logic we need to set up in here now. So to recap, whenever the AI wants to run this service, check that we're working with a BP enemy, access its perception component if we are, and say, and check, can you see the player character? If you can't, say, right, well, set your blackboard key state to patrolling. And if you can, set your blackboard key state to chasing player and your blackboard key target to be the player character. But notice, we haven't actually said anywhere what blackboard keys does this selector and this selector correspond to, and that's what we do in the behavior tree. And that's why these two need to be instance editable, or public if you prefer, otherwise we can't do this next step. So compile that and save. Then back on the behavior tree, what we want to do here now is put that service on this selector. So we can right-click the selector, go Add Service, and there's our BTS Check C player. Okay, add that in. And then just align. I like to try and keep this nice and aligned if I can do. We select the service, and we can see a few things. These are our 2 blackboard key selectors here, BB key state and BB key target. And then this is where we actually wire them into whichever blackboard keys they represent. So we're saying the one we call BB key state is meant to represent the state key, and the one we've called BB key target is meant to represent the target key. So that's how you plug in your services and tasks and things into your blackboard. Then notice down here, this service has an interval of 0.5 with a random deviation of 0.1. So that means it will run every 0.5 seconds plus or minus 0.1 of a second. So somewhere between 0.4 and 0.6 seconds it will fire. So we don't need this running 60 times a second, that'd be wasteful. We can just check every half a second or so, can you see the player? Depending on your exact needs, you can drop that or raise it if you want to. And then see whether this works or not. What we'll do, we'll just say, if we are in the chasing state, just move to the player. The way we do that is we click and drag to add a task to our chasing state, our chasing sequence, and you'll find there's a built-in task called move to. If we add that and then select move to, notice in the blackboard section for move to, it's saying, right, which blackboard key represents the thing you want to move to? And we want to set that to target. So object keys or vector keys will show up here. We want target. Let's just save that for now and see if this actually works, shall we? So if I go back and hit play, this AI can't see the player because we're hidden behind here, so they're in their patrolling state. Then if they get to see us, they will run towards us like this. And you can see this on the blackboard itself. If I just rearrange my screen a little bit, this is where having 2 monitors really helps. I mean, that doesn't help this screen recording, obviously. So I go play. There's no tasks under patrolling, but if there were, you'd see it trying to execute those. And then as soon as we go to being seen, you'll see the behavior tree light up. See, it's on the move to task now under patrolling, chasing, sorry. Okay. Now, one thing you may have realised, if you've tested that yourself, there's no way we would ever get away from this character without being able to attack them, at least, because they move at the same speed as us, so we can't outrun them. So what we need is a way of changing the AI's move speed. And what we're going to do is we're going to create our own task. So on the behaviour tree, sure, you've got all these built-in tasks, but it'd be pretty limited if that's all you had. But you can create your own tasks to do anything you want, and we're going to make a task which just changes the movement speed of the enemy. So when it's chasing us, we can set it to 1 speed. When it's patrolling, we can have a slower speed, so it's just walking around and so on. So how do we do that? Well, we have to click this new task button at the top, and then annoyingly, like with the service, it doesn't ask us what we want to call it. It just makes a new task called BT Task Blueprint Base New. However, if you go back to the content browser, you can find that and rename it. I'm going to call mine BTT for Behavior Tree Task _ set walk speed, because we're going to be accessing the character's movement component and changing their walk speed, so that makes sense as a name. So inside that, how's this going to be wired up? Well, the initial event that fires it all off is something called event receive tick AI. So that's saying when the AI wants to tick this blueprint or wants to run this blueprint, this is where it all starts. To begin with, we're going to do no, we need the movement component here, don't we? So we can do cast to character. I think characters contain a movement component. Well, we'll see. If we just go get character movement, yep, there it is. So why didn't we go cast a BP enemy? Well, our BP enemy is a type of character, and character contains the component that we need. So by doing it this way, this task will work for all characters, not necessarily just all BP enemies. So if we make other types of enemy or AI that also inherit from character, this will work for them. Then in here, we want a set walk speed. No, it's set max walk speed, isn't it? Set max walk speed, there we go. And we can wire this in like this. Now what we could do is just hard code in some number here, like I could type 200. And it means this task would only be capable of setting the max walk speed to 200. But we want it to be more flexible than that. We want to be able to say on the blackboard itself what we want to set that to. And that's easy enough to do. We just click and drag away from the set max walk speed, the max walk speed input, and do a promote to variable. And then we'll call that something like new walk speed, and make that an instance editable public variable by opening the eye icon here or ticking instance editable over here. What that means is this will show up on the blackboard and we can set it to whatever we want. Now the problem we're going to have here is the behavior tree will get, if it starts running this task, it will just get stuck inside here and never finish, because you have to put some nodes in to tell it when the task is finished and did it fail or succeed. And that is called a finish execute. We'll finish execute there and tick the success button, because if we went through all this and got to here, we've finished this task successfully. However, if this cast fails, we want finish execute without ticking success. That will mean the task failed. So say if we've tried putting this in for some reason a behavior tree for something that isn't a character, it will fail. That will mean the behavior tree won't get stuck inside this task infinitely. It will abort the task and try and do something else. Back on the behavior tree, we will now add a task to the left of our move to under chasing, and that can be our BTT set walk speed. We select that, and then here's where that new walk speed variable shows up. So for chasing the player, if we put the walk speed on something like 400, I think the character we're playing as moves at 600, so we'll be able to escape. And then if you think that title there, BTT set walk speed, is a bit annoying, we can rename that. See where it's got node name here, we can put go to chase speed. And then, in fact, matter the move to, we can rename that. We can put like go to player. See. I suppose set chase speed would be, yeah, set chase speed, go to player. The behavior tree will run its sequence tasks from left to right, so it is important that set chase speed is on this side of player, otherwise we'll move to the player, then change our speed. So let's save and try this and see what happens. So the AI initially can't see us, so it will be just stood there. When it does see us, it will start chasing, but notice we can now actually outrun it. We're moving at a faster speed, so it would be possible for us to get away again. And then when it loses sight of us, it's just going back to its patrol state, which contains no tasks at the moment. Then when it re-sees us, it chases. So the patrol state how do we get it to patrol around this little central piece in like a big square, is what we're going to set up in the next section.